Welcome back to part 2 of our building a B44.2 model. What I've done is I've gone away and just punched all the numbers through my calculator to get the actual dimensions that we need to enter into RC Crew Chief. So what we're going to do now is create the model. So we just open the chassis manager. First thing we have to do is create a model. So we don't want to just edit this information here. What we want to do is add a new chassis. So click that. Now what happens here is this will bring up a form that allows you to essentially copy an existing model. So if you are using or just taking a model and just making a few tweaks to it, this is a great way to do it because you can copy in all the alternate positions and your spring table and your roll bar tables, everything. In our case, we're not doing any of that, so we don't want to check these because we don't want to copy the alternate hinge pin positions for the JRXS Type R. And it really doesn't matter what chassis we pick here. We can pick any one we like. So we're going to enter in here AEB44.2 as our chassis model name, and then just click Add Chassis. So now you'll see we've got add chassis name and we've got all the information here that we need to fill in. So let's start away here. So the wheelbase was 286, front track is 245, rear 232, chassis 119, pinion. Too concerned about these numbers here. They can be changed in the setup form. I know the spur is an 81 tooth, and the internal ratio you want to make sure you got right is 2.5. I'm not going to worry about rotating mass numbers here. Those can be changed later as well. Okay, so let's click Save All there. Now we'll enter the front suspension numbers. So our tire diameter was 86, and the width was 32, right height was 21, and our camber was -1. Okay, so suspension arm, X1 is 24, 5. Okay, our upper camber link numbers, 7.1 for the X, 4.57 is the Y, and the length of the camber link is 64.59. And last but not least is our kingpin, 29.75 and 9.4 is the L axle. Okay, so we'll just click Save here. Now this brings up a graphic of what we've just entered, and there is a little bug in the program right now in this creating a new model. What it's done here is it's used the track width from the previous model that we had shown there. So if we want to get rid of this, let's just go back here and do Save All, and then go back to the front suspension, and there it's fixed. So that will be fixed for the next update. There's a new update coming up very shortly. So you should be able to take this, look at your car or buggy or truggy or whatever you're doing, and this should look exactly the same as what your real model looks like, because this is a scale drawing of that geometry that you've entered. So if you see anything here that doesn't look right, then you probably have a number wrong. Okay. Right, we've entered front and rear suspension. Now we need to enter our shock information. So we'll start with the front shock, excuse me, front shocks, and the number of mounting holes in the bottom shock here. That's 2, L1 dimension is 39.55. N dimension is 40.06, and our offset is 0, indicating that the lower shock mounting holes are right on the center line of the lower suspension arm. So the upper mounting point, we have 3 holes, and our X1 dimension is 24.79, Y1 64.95, 2.98, and 69.92. And we'll repeat the same process for the lower, or for the rear. Okay. All right, so now we have both our front and rear shocks entered. And for some reason here, it looks like we've got a strange number there, and that is because that is wrong. That is not 40.06. That should be 43.06. So just correct that, save it, and just preview that again. Okay, now we can see we've got our second hole there. And the rear shocks. Now the rear shocks are a little different because the rear arm has a dog leg in it. So the lower mount for the shock is actually negative. So that's why you see this down in here, and that's why we have a negative number for the offset. The offset, which is the offset from the center, or the line that joins the 2 hinge pins to the center line of the lower shock mount. Okay, so now we need to enter some springs, and Associated was kind enough to provide us with all the spring rates, so that's a good thing. All we have to do now is just punch them all in. So we're going to start with the front, because the springs are different front to rear. I always put a designation of front for the front spring, and then these are color coded, so we've got front brown, and the rate, oh, I'm going to have to change something here. We want to put our rates in pounds per inch, so we're going to switch to imperial, and we're going to do this again. Front brown, and spring rate is 2.85, and we've got front black, 3, and last but not least, we've got rear yellow, and that is 2.4. Okay, so there we go. We've got all our spring rates entered, and with a designation of rear for the rear ones and front for the front ones. So when you're selecting them in the setup, you make sure you select a spring that's appropriate for the end of the car you're applying it to. Okay, so we're just going to save that. The last thing to do here would be anti-roll bars. Unfortunately, I don't have any on this car. If you did, there's, depending on what configuration, we've got a wire type, which is the most common, and then we have a wire plus a blade. So this is usually a very thick wire, and then with a machined blade section in the center between the 2 mounting points. We have a wire plus bar. This is like the Associated TC 6.212 type, where you have a bar with just 2 wires. And then there's the blade type, where you rotate the blade to adjust the stiffness of the bar. And then there's a wire beam type, which is used mainly on the large scale cars. So you select the appropriate one and just enter the values. We'll just do pretend one here. So we'll say this is going to be soft, and what I'm going to do is I'm going to change my units back to metric. And you should actually do this before you click Save All, because you will get a little bit of rounding differences if you save everything in Imperial, because everything is saved in metric. So what it does is it converts whatever is displayed on the screen back to metric, and so you will get a little bit of rounding errors when you load things back in again. But just very, very minor. But just for consistency, I always save in the metric units. So let's say we have a 1.1 millimeter wire. Let's say our L1 is 25, our L2 is 35, and our radius is 30. So we just calculate that. There's our roll bar stiffness. We can copy that to the anti-roll bar table. You can put in here what that bar diameter was and the length to where the bar connects to the suspension arm, which we actually did measure. So we can actually put in the true value of that, which would be 27.25. Let's call it. And then you would save. And again, well, we would give this a name. So we'll call it front soft. So again, if you have different anti-roll bars front and rear, put a designation front on them and to allow you to determine which one should go on which end of the car. So I'll just click save. And last but not least, go back to the beginning and just as a double check, just click save all. Now the last thing I always do is I go in and put my alternate positions in at the very end. So we have some alternate positions to put in here, so we're going to go ahead and do that. And what we have on the front is we have two positions for the we have two positions in here for the camber link, and we have two positions out here at the outer hub. So let's enter in here the alternate positions. Now, first thing is you want to, well, as I said when I was measuring, you want to make sure you pay attention to the shims. The position that we measured had one shim under the ball stud, and the ball stud was below the top deck chassis. So that position, if we want to get back to a 0 point, I always like to have the 0 point, we need to add 0.78. So this position here that I just added now represents the camber link position with 0 ball studs underneath it. Now we also had another position that was inboard of the one that we measured, and the position of that, unfortunately I forgot to calculate that number, so 2.68 is 3.8. So it is 3.8 inboard, so it'll be minus, and then we would have a 0 point, a point with the shim underneath it, and then we would have, we want to get to the point where there's no shims. So there we have, that should be 0.78. Okay, so we got 4 positions there. We just save and exit that, and now we can see that those positions are represented here in our graphic. The outer camber link position, we had was measured with the camber link in the outermost position, so we have minus 3.6 is the inner position. And that's it. Okay, so we do the same thing for the rear. Okay, so there we go. We've got all our alternate positions entered. If you had shimming or something that was going on underneath the hinge pin, you could enter in those values as well. But we don't. So that's it. So just click Save All just to make sure we've got everything saved. And that's it for the chassis. All right, now we have completed entering our chassis, and in order to use that chassis we need to build a car. So we're just going to open the car manager here and build a new car. So let's call this buggy B44.2. I always like to put either car, buggy, truggy as a prefix. So it just makes it easier when I'm looking down the list to identify what I'm trying or what I'm loading. Total mass we don't really have to enter if we are going to calculate our center of gravity, because that will be done and filled in for us. So I'm not even going to enter that number. You can enter it though, but I'm not going to. So I'm just going to enter our unsprung mass, 186.1, 182.5. So now we can go to our CG, and I'm just going to put the CG calculator and pull it up. So we measured all the corner weights, so we just have to punch them in. 400, 7, 423, and 441. Okay, so on our wheelbase was 286. And our track width, and we need our track width number to the center of the wheel. So we're just going to, the front track width was 245, and we had a 32 wide tire, so that makes it 213. And the rear track is 232 minus 32 would be 200. So there's our track width. Our loaded tire radius, our tire diameter was 86, so the radius would be 43, and because there would be a load on it, it'll be slightly less, so let's call it 41. The height at the rear is 102. That was the height of the stand that I had the back of the car set on. And the weight on the front wheels is 804.9. So I'll just click calculate, and there's our CGX, CGY, and the CG height above ground. So copy those values to the car and close this out. And so now you can see it's totaled up our total mass, and it's entered in the CG, X, Y, and height values. So now all we have to do is select our components. So we want to use our AEB44.2 chassis. Motor, let's do a powers 13.5 with 0 boost. Battery, that's fine. ESC, let's use Pro AC. And that's it. Save it. Close out. And now, when we go down here, you'll see we have a buggy B44.2. And now you can go in and start playing around. If we go into setup first, there's going to be no setup. Obviously, we haven't entered one yet. So if we just click OK, what it's going to do is it's going to set everything up using the default values that you entered into the car or into the chassis manager. So let's just call this a I'll call it sample. Example. It's not going to be really representative, but normally what I would do is the first one, and I will do this, is I would go and enter in what the basic kit setup values are. And so select put a rear black and the front. So you can see here now it's good that we put the front and rear designations on here so that we know which is what, and you can enter in all your shock values and all that sort of stuff. But I'm not going to get into a bunch of setup stuff here. The purpose of this was to show you how to measure and create a model, and we've done that. So that's it. We are finished.